Hey everyone, we're going to pick up where we left off working with arrays and talk about these topics here in this video, the length field versus the length method. We're going to work with arrays of objects, of custom objects, we should say. We're going to work then when we have a bunch of information, we're going to be able to search for pieces of information. So that's a sequential search. We're going to be able to, I should say, binary sort. And finally, we're going to perform a binary search. So let's. This is called a selection. There we go. Okay, so the sequential search, the selection sort, and the binary sort are the three things we're going to talk about. Starting off at the top, the length field versus the length method. So let's go ahead and create our array of names. So we've got three names in our string array, and if we do a system out print line names dot length, this is our length field, and what the length field determines is the number of elements in the array. So length field returns number of elements in the array. Okay, so if you count 1, 2, 3, there you go, 1, 2, 3, and there's our output. The length field, you notice there's no parentheses. It is just a field that's public, that's directly accessible through the string class. So if we take a look at then versus the length method returns the number of characters in a string. So if we do a system out print line Joe, or we can even say names sub 0. So it'll say Joe has name sub 0 dot length, and you can see here we have parentheses behind the length, which makes it a method. So this is the length method. So this will say Joe has 3 characters in his name. And as a matter of fact, just so it's not going to return the same number, like this would be 3 for the length field and 3 for Joe. Just to demonstrate it, we could say name sub 1, just so you could see that Chris has 5 characters in his name, and so the length method returns differently than the length field. So those are the differences there. Moving on to arrays of custom objects. Let's go ahead and create our custom object student. And let's just give our student a name field. Student fields, private int student ID, and we'll call this first name, last name, age, and student ID. So now I'm going to necessarily have to create any constructors or mutators on this, just to demonstrate arrays of custom objects. So we are now creating an array of student, and we'll call this student list equals new student, and this is how we declare how many students are in the array. So if you're working, you got a big school, let's just say 20,000 students, and so we now have 20,000 elements inside of this array. However, it's really a two-step process. Yeah, we have to create the array, which is what the keyword new here does, is it instantiates an array object. However, we also have to create all of these students, in memory. So um, I might just shrink it down just a little bit. So I don't know if it goes slow. Let's just create 200 students. So in order to do that, we have to instantiate all these objects. Let's use a loop for int I equal to 0, because student list sub 0 will be our first student, while I is less than student list dot length, and we now understand the difference between the length method and the length field. So and increment I. And now we'll say student list sub I, sub 0, sub 1, sub 2, all the way through 199 in this example, equals new student. And we have now, instantiated all of our student objects. So I always kind of view this as two parts. First part is to create the array. Second part is to create the objects. And so when we're working with arrays of custom objects, those are the two parts, and that's how you work with them. Then you can work with all of the methods of student. We didn't create any, but if we did, we could work with them as working with subscripts like we normally would. So student sub 0 would be the first student, student list sub 1, etc. So we've covered a lot of stuff. How do we work with arrays, and a lot of different concepts. But once we have a collection of data, and arrays are just one type or one way that we can store a whole bunch of data. The things that we commonly need to do with groups of data are perform searches, and a sequential search, being able to find a piece of information, is just kind of the most simple, straightforward way of working with searches. And it's not the most efficient. It's not the fastest or the most complex. It's just very basic, and so we always kind of start there. What's the most simple way to learn to search through data? Now that we have an array, maybe we have 200 students, and we need to see if student with student ID, blah blah blah, whatever the number may be, if that student exists in our system. So we need to search for a number. And so we have our string of names. And so I'm going to go ahead and I'll create a method to perform the search. So just that way we can call it several times, right? So we don't have to write the logic several times. If we want to perform several searches, we just write the method and then call it. So I'm going to write a public static method. It will return the position that the number was found in. So it'll return an int. We're going to call it search. It's going to accept an array called names, and it's going to accept the name string, and it's going to accept a string for the key, like what name are we looking for, and it's going to accept an array to look through. Go ahead and create a for loop. Matter of fact, I was going to do an array of ints, but since we have a names array already, I'm changing my example on the fly here to work with strings. For int I equal to 0, I less than names dot length, I plus plus, and the logic is not really that complex. A sequential search is just going to start at position 0 and loop through each element in the array one at a time until it finds the result that it's looking for, or until it doesn't find it. So we'll say if names sub 0, it shouldn't be name sub I, so that way the name changes. If name sub I dot equals our key, return names sub, actually we'll just say return name was found. And if it hits this return statement, that will finish this method outside of our loop. If name was not found, we'll just go ahead and return name not found. So in our loop, it's going to loop through each one of the names, and if it does find it, we'll say name was found, otherwise name not found. Let's go ahead and call our search method, and the first thing we need to pass it is our array called names. I'm going to pass it the names array, and we're going to search for Evan. And we'll put that on a print line, so it's either going to say name was found or name not found. Since Evan is not in our array, this should print out not found. Let's see if it works. There we go, name not found. Now, if we change it up, let's search for a name that is in there. Name was found. Because Chris was in there, we're searching for Chris. So now we have a method to perform a sequential search. Thing is that a sequential search is not efficient, right? So if you've got 1,000 elements, on average it'll take 500 times to through a loop, 500 iterations through a loop to find the value that you're searching for. So there are many other algorithms to search for information, and this is just the most basic, so we start there, and then there are others like the binary search that are slightly more efficient, and then you have other searches that are much more efficient. Searches are a topic that people are still researching algorithms and trying to figure out ways to perform faster searching. Since programs search all the time, there's still research going on for ways to try and improve it. So let's get into another one of those methods here in a little bit, the binary search. But before we perform a binary search, let's work with sorting information. Since looking for something is something you commonly do in your programs, sorting information is something else. I mean, just think of an Excel spreadsheet, and you've got a column, and you want to sort that column by in alphabetical order, or you want to sort that in ascending order. Those are features that you commonly find in programs or applications. And so the next concept is a selection sort, and it's going to perform a sort. And so I'm going to go ahead and write another method that will sort. In this case, I'll go ahead and make an array of integers, and we'll put them out of order, and for this demonstration. So some random numbers here. So we have random ordering of numbers in a numbers array. So let's go ahead and write our method. So this was our sequential method, sequential search. Now this is our selection sort method. Okay, and this method is going to be public static. We're not going to return anything because we talked about arrays passing by reference. So when we pass an array into this method, it'll sort it, and it will be changed back in the main method. We're going to call this selection sort. We're going to accept an array, and in here we're going to call this array nums. And let's go ahead and make a few. Let's start with a for loop. Int I equal to nums dot length minus 1. While I is greater than 0, we're going to decrement I. Go ahead and create a variable for one called first and one called temp. We'll use those here in a minute. For integer I equal to nums.length minus 1, I greater than 0, decrement I. So let's go ahead and initialize first equal to 0, and this is our subscript. First is going to represent our subscript, and we're going to start it off at 0. So initialize our subscript to the first element 0. We're going to have an inner loop for int j equal to 1, while j is less than or equal to I j plus plus. Say if num sub j is less than num sub first, so if one number is smaller than another, then set first equal to j, and our array is called nums, not num. And then we're going to set our temp equal to num sub first. This is going to swap the smallest found with the element in position I. I'm going to set num sub first equal to num sub I, and then set num sub I. So we're kind of playing a swapping game here. I keep saying num because it's in my notes, but it's nums. Okay, so this is an algorithm here that's going to essentially sort our data, and realize here we have data in random order and sequential search. Let's see, the sort in descending order. So let's go ahead and call our selection sort. So we're going to call selection sort and pass it our array here called numbers. So now numbers should be sorted if our method works. So let's go ahead and do the shorthand for loop for int I and numbers. And so after the name was found, it should print out all of our values in order, in descending order. There we go, 87, 77, 56, 24, 23, 5, and 1. So our selection sort method worked. And so, this algorithm here, you can easily find these. in a textbook somewhere online. Selection sort, again, this in the academic world we use a selection sort all the time, so I don't know that it's necessary to memorize it as much as it is to understand the logic and the steps. And anytime you need to look it up, you can look it up, but understanding what's going on in here is the important part. So we're going to go ahead and stop this video here, and since we're about 20 minutes in, we will pick up with the next video with the binary search. So that is coming up.